Maybe. Okay, there we go. Okay. So we're good on homework then?
Yeah.
Yeah.
All right, question 3. You're using the self-efficacy data file, and you're rounding after your calculation is complete. Given the linear regression equation, y equals 2.0 plus 1.5x, what is the y-intercept? I said 2.
Agreed.
Yes.
All right, I'll go next. Given the linear regression equation, y equals 2.0 plus 1.5x, what is the slope? I got 1.5.
Yep.
Yes. Given the linear regression equation, y equals negative 3.0 plus 0.25x, what is the predicted value of y when x equals 16? And I have 1.
Me too.
Me too.
I like it when they're short and sweet.
Given questions use the data file math self-efficacy, be sure to use the confidence data for the explanatory variable and the score data as the responsive variable. Make a scatter plot of the math self-efficacy data. I'm sorry, I can't read. Of the 3 data shapes introduced in the reading, which shape best describes these data? And I said the hot dog shape.
Agreed.
That's what I put.
Okay. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? And I put simple linear regression is appropriate for these data.
Me too.
Yeah.
So the first one?
Yeah.
Yeah.
So my understanding is that if it starts looking more like a hamburger shape, then it starts not being appropriate. Is that right? Because then it starts getting too spread out and the data's kind of all over the place. Is that right?
Yes.
Yeah.
Okay. How many observations are in the data? And I have 138.
I had 139.
That's what I have too.
Oh, was I? Sorry, I was off one. Okay.
Yeah, I have 139. Okay, what is the y-intercept? I said 18.69.
Agreed.
I have.
Okay. What is the slope? And I had 12.695.
Yes.
Sarah, you agree?
Yes, sorry.
Okay.
What is the predicted value of y when x equals 4? And I have 69.47. Is that right?
That's what I have.
Okay.
I had 69.469. I think you have to leave 3 decimals or round to 7.
Well, I think you have to have 3 decimals, but let me go make sure.
Because I did 18.690 plus 12.695 times 4. So I added it. I had the 3 decimal places, but that's still what I got.
I still have 69.47, even if with all 3 decimal places.
Yes, yeah. I have.
Okay.
Do you want to check it?
I don't know what I did or how I got to that, but I mean, we'll see at the end. I'm gonna write that down, and then we'll see when we go to score if that one's off.
Because I've done it 3 times and I got the same answer all 3 times.
Okay. I believe you.
Yes, I did. All right.
Is it my turn? Whose turn?
I think it's my turn, isn't it? Did Marianne?
I just went, yeah.
Number 12, the confidence data resulted from the students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Round to 3 decimals. Hint, because there's a positive correlation We can use the largest x value to find the largest predicted y value. So I have 94.86.
That's what I have.
Okay, I have the same issue on that one too, but we'll see what happens. I'm gonna agree.
Did you do these by hand, or did you do these through SPSS or Excel?
I did it in Excel, SPSS. Kind of, I use it kind of like Excel though, so that's probably why mine's different than your guys's.
That's probably why, because I did mine by hand.
Yeah, I did too.
Oh, so that might be different. So I'm gonna write that one down too, and then we'll just see at the end.
Okay. I think it's you, Russell.
Oh, sorry. How many explanatory independent variables are present in simple linear regression? I had 1.
Yep.
How many response-dependent variables are present in simple linear regression? And I have 1.
Yep.
Agreed.
A company in South Dakota manufactures hard hat used in the mining industry. They recorded measurements on all the hats they produce for quality control and planning purposes. The measurements they collected include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable? And I said the size of the hat because it's the variable being predicted.
Agreed.
Agreed.
I'll submit it.
Okay.
It says we got 100%.
All right. Good work.
Perfect.
Awesome. All right.
Yay.
On that describe the data thing, what would be a good graph to use, do you think?
A good
You
graph.
could do side-by-side bar charts, couldn't you?
Do a what?
Side-by-side bar chart comparing marshmallows and the...
Yeah, or do you think... No, that wouldn't work, because there's not 2 variables. Yeah, that might be what I do. Unless anybody else has another idea. Do you have an idea, Russell?
No. I think the bar's a good default. Try it.
Or you could do 2 pie charts.
You could.
You
Because
could.
35% would be this many percent is average. I don't know.
But see, in this case, because you're using a measurable amount, you wouldn't want to use the pie charts because pie charts are usually categorical.
Well, I don't know. Okay.
So I would use a side-by-side bar chart.
The histogram?
Because that way you could actually show the variation in, like, there's way more crunchies in this cereal than there's marshmallows. Like, you can actually visualize the ratio between the two.
Yeah.
That would be, strictly speaking from the textbook had suggested using pie charts as categorical data instead of quantitative.
Do like a histogram of all of the samples?
Yeah.
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 Okay. I'll figure it out. I'll send it out as soon as I figure out how to do all of this. And then you guys can go over it and proofread it and all of that stuff.
Okay.
Because I have all the data done and I have all the information, I guess. I just have to write it all out.
Sounds good.
I'll send it to you guys either tonight or tomorrow.
Okay.
All right. Sounds good.
Thanks, you guys.
All right. Thanks, guys. Have a good night.
You too. Bye.
All right. Bye.